Guofu, and I will be talking to you about my 2212 Lab 1 today. This lab will be exploring the fact that objects can acquire an excess or deficiency of charge through interactions with other objects, and also calculate how much charge there is present on this piece of charge tape that we will be creating. And this will give us an understanding and an idea of how much charge an ordinary object can hold. Our experimental setup, we're attempting to float one piece of tape above another one. And by taking the distance between the tapes when the floating occurs, we can use our physics formulas to calculate how much charge is on each piece of tape. We first created two pieces of charged tape by ripping them off of another piece of tape so that they gained more electrons. And then we arranged our tape as charged tape as shown in the diagram. And so there's all of our initial data on the tape. And so we brought tape A up towards tape B, and when it reached the distance became close to 28 millimeters, tape B started to float. For our calculations, we had to assume that the tapes had the same charge because we created them the same way, and we also approximated tape charges as point charges to make it easier to calculate. And so, because we knew that the force of gravity and electric field canceled out, they had to be equal to each other, and then so we can expand those equations and then solve for Q. And so what that would give us is that the tape has a charge of 1.307 times 10 to the negative 8 coulombs. For the simulation, all it really is just defining of constants and the slider. So that's all of the input that we have, and then the program will calculate using the while loop to how much force the electric field is creating depending on what charge it is. So you can play around with the slider until the forces approximately cancel out. And then there's obviously the defining objects and all of that that's in the code, which I've omitted in this slide. We determined the charge on the tape to be approximately 1.32 to 10 to the negative 8th power coulombs. And we know it's reasonable because it's between one electron and every electron in the tape. And so according to the lab notes, we can they give us the dimension of an atom, so we can kind of calculate how much atoms there are and how many other electrons were gained per atom, which is that each electron gained 2.4 times 10 to the 12th atoms on the tape. Post-lab questions: if the electrons had and protons charges were reversed, nothing would really change because they would still be opposite charges, so they would still interact the same way, except their names would be kind of different. There's not really a meaningful change there, and it's important to handle the charged tapes as little as possible because any contact will discharge the tapes. Lab, we floated a charge tape above another one, so we can use our knowledge of physics principles and our measurement of the distance between the tapes to calculate the charge of the tapes. Some sources of our error were that the tapes probably did not have the exact same charge because even though we created them the same way, there's no way to ensure that we charge them exactly the same. And then handling the charge tape could have discharged them. So there was a moving target there, and there's a lot of electromagnetic fields like wires and computers and things in the lab area that would have interfered. And of course, the final charge is 1.307 times 10 to the negative 8 coulombs.